Therefore, the first step before doing the analysis, after data collection, before you going over to do the analysis, there is a step here. This is the very important step. It is the checking for errors, error checking. Okay. So where is this error checking? At which step? If I ask you in the exam, if I give you data collection, analysis, presentation, you should be aware that it is after data collection, you have error checking. Then you go for the analysis. That's natural, of course. That's very clear, but just giving an example of a study, of an example of exam question. Most commonly, we make typing errors, but there might be also some measurement errors, which is inevitable. You will have errors in any exam. Yeah, there are hypothetical errors, practical measurement errors, and errors when you are entering the data. Since we are not sure whether it is a typing error or we always have in any data set, we have the ID, participant ID, from 1 up to how many participants we have, an order of participants. When I think that this age should is it 46, 60, 64 or something else? And if I'm not sure, I should be able to find the participant and remeasure it, to go to the file and look whether it is correctly typed or is there a typo, typing error. Therefore, we have this participant ID always. In any data set, it should be there, a unique identifier of the participant. How do we check the errors? If you have a categorical data, it is relatively easy to check for the data, for the error. Let me show you how I do it. Showing is mostly more efficient than talking theory. Okay, therefore I want to show you. I have here how many variables. These are all my different variables. When I go to the variable view, I see I have 13 variables. The first variable is the IP, and the others are the study variables. So 12 study variables. Now, I want to analyze descriptive statistics, and I want to see the frequencies. Frequencies of a categorical variable. As you see, the numerical variable are presented here as a ruler, as a scale, and the categorical variables either as steps or circles. Sex, for example. Let me see the frequencies of the sex. Are there any mistakes or not? You look at this table, please. You see that we have how many males? How many males in the data set? 241. 41. How many females? 195. But there are some 3, some 4, some 1, each one. 111 and 1 person typed as 22. So clearly this should not be there. There is a mistake, there is an error in feeding the data. Okay, so what can I do? I come back to my data, I click on text, right click on it, that's the easiest way, sort it descending or ascending, better descending here, and then I can easily identify this person number 230. Now I have to go to the questionnaire or data collection tool 230 and see what is the sex of this person. Most probably it is a typo. I will see that most probably. I will see that it should be 2, but I mistakenly, I typed it as 22. Here it should be 1 probably. Probably I am telling you, okay? But I typed it as 11. This 4 and 3 is not in my database, okay? The categories of sex, when I go to the variable view, I see that the categories of sex is either 1 or 2 in this example here. I don't have a 3 or 4. So if I see 3 and 4 here, it is certainly a mistake. Either I have to find it, or I have to remove it. I have to find it correct, or if it is, I cannot identify, I cannot remeasure it. I don't know, I'm not sure whether it was a male or a female, then I have to leave it as missing that data, because it is not known, of course. False data is not acceptable. So for categorical data, the easiest way is to check for the frequencies, okay? If I ask you in the exam, what is the easy way to look if there is an error in typing the categorical data, your answer should be what? Checking for the frequencies. Checking for the frequencies. You can, of course, visually inspect your data, look at it visually, all the data, but if you have a data set like this here, 400, 500 cases, then it will not be practical to look one by one by your eyes. You should have a better method, which is looking for the frequencies or ordering the data. Also, ordering data would help. If you have a numerical data, it is more difficult. Here, you may check the range, look for the range, look for the range. How can I look for the range? Again, I can do which numerical data I have here. This age is a numerical data. Let us see. Age is coded as scale, you see, numerical data. So I can go and look for the frequency again of the age, frequency of age, okay, frequency of age, display frequency tables. Here I will see the range. The range is from 22 years of age up to 99 years of age. So by looking to the range, I can have a clue because the minimum and maximum values should be acceptable in an acceptable interval. Can it be possible that a person is 22 years of age? Yes, it is. 24 also possible. Can it be possible that a person is 99 years of age? Yes, that's also possible. In this case, I could not identify any possible errors in typing the age. Let us check for another numerical data. For example, weight, okay? Analyze, descriptive statistics, frequencies. And now, instead of age, I want to see weight, because it is also a numerical data. I want to see the range. Range is from minimum to maximum. Minimum weight is 33. Is it possible that a person is 33 kilograms? Yes, it is possible. But since these are adults, an adult of 33 is suspicious. Better I go and check whether it is true or not. I go to the maximum values, and in the maximum I have what? 160. Is it possible that a person is 160 kilograms?
Yes.
That's also possible. But again here, I will be suspicious. I will have some doubts. Therefore, I go and again here, I click, right click, I sort it ascending or descending, doesn't matter. And now I see that the person with a weight of 3 kilograms is which person? The person with the ID number 215. So I easily can go and approach this person and remeasure his weight, or look at his file whether it is correct or not. Or I can sort it descending and look for the ID of the person with the highest weight. This is 428 kilograms. And again, I should go and check. If you checked, that's an important point, and you found that there is an error. There is an error in typing. What you should do? If you have extreme values, what to do? Let me repeat my question. My question is what to do with the extreme values? With extreme values. Because if you have extreme values, it will affect your analysis. It will affect your analysis. Let me give you an example for the extreme values. Here, let us have a new data set, and this is, I have a one variable, which is, let's say, weight, okay? Weight of the participants, weight in kilograms, let's say, okay? Weight in kilograms, and this is a, of course, scale variable, numerical variable. Now I type the weights. One person, I have 45 kilogram. The other one, 45. The other one, 62. And another person, let's say, 47. And the last one, 77. Okay. These are my participants. Now, if I go and analyze descriptive statistics and descriptives, I want to see the descriptives of the weight. Let us see what we have. Here is the outcome, the output. We have a mean weight of 57. The mean weight of 57.7 kilograms. 57.7 kilograms. Yeah, that's acceptable. But if I have two extreme values here, let's say one person who is 160 and another one who is 157, just to have extreme values, okay? And I reanalyze it, descriptives. I should have also the medians. We will discuss later what mean, median, standard deviation, variance, kurtosis. Here we don't have median. Analyze descriptive statistics. We have also here the option of calculating the median. Statistics, median, mean. I want to see the mean and median, okay? Not the frequencies. You see, although the median did not change much, it was 57, it is 69. It increased, but not too much. But the median, the median did not change much, but the mean has increased very much. It is 91. That means these extreme values, they are changing your mean and modifying your mean, which is preventing you, disabling you to do some hypothetical tests, some hypothesis tests, namely the parametric tests. You remember the parametric and non-parametric tests? Okay, and let me ask you a question. If you have a numerical data, also from the last session, some numerical data, and you have two groups, and independent groups. Which hypothesis test you have to perform? We have to do the t-test. T-test is correct. Did you say paired or independent?
Paired.
You have said paired. Paired is not correct. Independent. Please remember who was speaking. Miriam, thank you for the answer. It is correct to some extent. If you have numerical data, two groups, you do the t-test. That's correct. But paired t-test is for measuring in the same person, So it is not independent, it is paired. If it is independent groups, then you do the independent samples t-test. Okay? And what was the alternative of independent samples t-test?
Last time you did man witness test.
Wow, you're surprising me. I was not expecting this answer. Thank you. Congratulations. Yeah. Man witness test. Okay. So this independent samples t-test is, we call it the parametric test. Parametric test. And this man witness test, we call the non-parametric test. Okay. Non-parametric test. We usually want to do the parametric tests. However, if you have extreme values, if you have skewed data, then it is not possible to do the parametric tests. And we want to do the parametric tests. So my question is, what to do handling outliers? What to do if you have extreme values or outliers? What to do with the outliers? After having my answer to this question, I will have a break. Any suggestions from the class?
Maybe we should divide them.
Miriam?
Maybe we should divide them. Like
You should do what?
divide.
Divide. Okay. The question is what to do with the outliers. And I am now listening the answers of the class. What to do with the outliers? What to do with outliers? Yeah, one suggestion is divide them, make them smaller. Okay. Other suggestions?
Maybe we can remove them.
Remove them. Yeah, remove them. Other suggestions? Saikal, Rakat. Whom else? I didn't mention the name. Any other suggestions? Delete. Yeah, delete is similar to remove. Okay. Delete. I know that there are other possibilities.
Maybe there are some tests.
We will do what, Bagimai?
Another test.
Another test. Yeah, good.
I don't know the name of their.
Okay. Leave it as it is, huh?
Yes.
Leave it.
Find
leave
another.
And perform another test.
Yes.
Very good. Yeah. Okay. Yeah. Test. Yeah. Very good. These are all possibilities. Removing is usually done, and we can also let me tell you, modify it. Huh? Modify the scale. The scale. This we call that data conversion. Data conversion. Don't worry. I just want you to know the term data conversion. We will have a session for this. So now I want you to reflect about this outliers or extreme values, or they can call it also extremes. Extremes. In order not to forget this topic, I want you to think about the population, the people around you. In the community, in our community, we have outliers and extremes, don't we? In your class, are you all the same? The same mentality, same political views, same lifestyles,
No.
No.
same beliefs?
Different.
No,
No.
you
Of
are
course, we
different.
have
You are different.
differences.
You have differences. And if you have differences, it is, of course, differences make it difficult to work together. Because here, with data, we make the analysis, but in the population, in the community, we have to work together. So if you have data, you analyze it. You analyze it. If you have a community, you work together. Work together. Both is difficult, of course, if you have outliers or extreme values. But what you do if some of your peers, some of your friends in this class here, for example, Hamza, he is an extreme value. You divide him, you divide the class into, for example, boys and girls, into leftist political views, right political views, believers, non-believers. Do you divide the class?
No.
No, you don't. That's not a good option. Okay, what else? Do you remove somebody who is extreme? If Islamic is extreme or outlier, he is not thinking like you.
No.
No,
Wearing
we
the
should
same clothes.
accept
Yes.
everybody. Yes.
Yeah, removing is also not a good option for the community. The same applies for the data. The same applies for the data. Deleting him, of course, we cannot delete any colleague. They are our friends. We love them. So the best option is leaving it and performing another test. This is the good option. We never delete or divide or categorize a group. Grouping should be done. Some other examples may be grouping and analyzing into groups. Also, although it is possible, we prefer to leave it, but we have the right to go and check. You have to go and check whether it is really an outlier, because it is, of course, difficult to work with the outliers. But if he is an outlier or she is an outlier or our data is an outlier, we have to find a way to work with it. And I will show you in the next sessions, I will show you some ways like the data conversion. This is one possible way to work with outliers or the extreme values. Okay, did you get the concept? Never forget this. As in statistics, we never delete, remove, or divide the data. We also in the community, we should never try to eradicate or change our data. Do not try to change Janan's live views, clothings, beliefs, external appearance. We never try to change this. Instead, we try to leave it as it is and try to find another way to work with it. Clear? This was a bit philosophy,
Yes.
but I think
Yes.
it is very useful. Okay,
Yes,
so
Mr.
let us have a break. Dr. Azamat, can we have a break? 10
Yeah.
minutes?
10 minutes break.
Okay. After 10 minutes, we will be again together. Of course, we will suffice with the bar graph, the pie, the histogram, the box plot, and the scatter diagram. So 5 types of graphs. I want you to know what they are, how they look like, and where they are used, which kind of data, for which kind of data they are used. Box plot, and 5, the scatter diagram. Let me go to SPSS and perform one by one these 5 different graphs or diagrams. Bar graph. Bar graph. What does it look like? You already know it, I'm sure. We can do these graphs from Chart Builder or from the legacy dialogues. Let me check the Chart Builder. Okay. As you see, there are different types of bar graphs, different subgroups, like the stacked one, the scale one, the 3D bar graphs. We will do a simple bar graph. Double click on it and move education here. Okay. Let me see the output. Here it is. I have a bar graph. Education of the patient. None. These are the categories. This education is what kind of variable? It's a categorical variable. Categorical, ordinal or nominal?
Nominal
Ordinal, it has order.
or ordinal?
Ordinal. What does Yasin think? Faiz Yasin, are you there? Yasin Hussein? Faiz. Okay, from now on I will...
Yes, sir, I'm here.
Tamam, thank you.
What do you want me to say? Which one?
This education of the patient, what kind of
Sir,
data?
it's category variables.
Categorical. This, because it has categories, as we see, it has four, 5 categories. But is
Yeah, and
it a
category is
categorical
divided into numerical and
is this categorical variable ordinal or nominal?
sir, it's not numerical because
It's not
it's numerical.
numerical.
Numerical categories.
Hey, don't get confused. Numerical is something else. We have numerical variables and categorical variables. And categorical variables
Ordinal
can be
variables
nominal
because
or
the
ordinal.
order in this.
Okay.
Yeah. Okay. I want 100% correct answers always, please. These are very
Okay.
simple concepts now. You should be very
Yes,
good in
it
this.
is.
Yeah. Education of the patient. This is a categorical and, of course, ordinal, because it has an order. You see, non-primary, intermediate. It is the educational level is increasing, and see how we coded it here. How we coded it here. Educational level. This is here. How we coded it? We coded it as ordinal variable in steps. Okay. So then, and here in the y-axis, we see the count, the number of persons. Then, is it okay that I write here a bar graph? We may use for categorical variables. Yes. If your data is categorical, you may do a bar graph. Very simple. You may do a bar, but it is also possible to do a bar graph for other types of chart builder. Let me go back. Okay, double click on my graph here. Sorry, I'm in the wrong screen. I should go here. Graphs, chart builder. Okay. Now, I want to make a small modification. Instead of education, only education, I will move another variable, let's say the weight, to the y-axis. And let's see what it looks like now. You see, the y-axis was before the y-axis was the count, the number of participants. It was the number of participants, the count or the frequency. Now it become the mean weight, mean. It become the mean. And still we have in the x-axis, we have the categories of the educational level of the participants. Therefore, I want to add here a bar graph is possible also for looking for the mean of the or numerical variables. It is also possible to do numerical variables. It is the bar graph can be performed also, can be used also for numerical variables. Let's keep going. Graphs, chart builder. I want to do a pie. Pie, here is the pie. Double click on the pie. Can I do a pie graph of a numerical variable?
Yes.
Yes.
Yes. For
Yes.
example, age, pie of age.
I think no.
Let's do it first for the categorical variable. You see, I drag and drop. I drag education and drop it here to the slice and select OK. Educational level. Now I have the educational level of the participants presented as a pie graph. Education of the participants as a pie graph. And this blue is known, half, almost more than half of the participants has no education, and primary school is almost a quarter of the participant has no and so on. The total of the pie is of course 100%, and here in the slices represent the percentages, the percentages of the each categories. What kind of variable I used to do a pie graph? Numerical or categorical?
Numerical.
Categorical.
It is a categorical variable.
Yes.
If I do it for the sex, it will have, of course, two categories only. Sex, it has two categories, male and female. Males are a little bit more than females, as you see. So categorical variable. Can I do it for the numerical variable, like weight or age or height? Is it possible? You see? You see the symbol? It's not possible. I cannot move a numerical category, numerical variable to here. It's not possible to move it here. Okay? Therefore, the rule is pie charts only for categorical variables. Just imagine if you had done it for a numerical variable like age, you would have 100, almost 100 slices, very small slices.
Yes, if we categorize it, we can, right?
Yeah, if you can categorize it, you can do it. But if it is numerical, it's not possible. Okay. Let's do a histogram. Let me show you what a histogram looks like. Histogram. I will do now an histogram. Chart builder. Okay. Where is the histogram? It's here. You see there are other types like dual axis, high-low, pie, area, line. But I want you to know the rules for these five most commonly used graphs, diagrams. I double-clicked on the very first simple histogram, and here is a checkbox. I will check it, the normal curve. Check the normal curve. I can do it for the sex, but I will do it for a numerical variable. And I want to show you the histogram of weight. What's happening? Weight. Okay. Display normal curve. Apply. Okay. Here I have the histogram. It looks very similar to the bar chart, isn't it? The bar chart had also columns. Histogram has also columns, but there is no gap, no space between each column. There is no gaps. All the columns are close to each other. A histogram is used to give us an image of the distribution of our variable. It is giving us an image, an idea about the distribution of our variable. Look, we have here weight starting from 0 up to 100 and something, and in the y-axis we have the frequency, the number of each value. Most of our participants have a weight of between 50 and 100. Let's say this is around 70, possibly 70, 75. Most of the participants, like how many? 80 people with a weight of 75. And there are very few people with a weight of less than 50. This is probably the one with the 33, one person. And there are also some with a very high body weight, 150 and more than 150, maybe 160, this one here. So very few ones, only one. And this curve is showing me the normal distribution curve. Is it symmetrical or not? This is very important to do the parametric tests. When you want to perform a parametric test, you want to have a symmetrical curve, symmetrical distribution. Is it symmetrical here?
Yes.
Can we claim that it is symmetrical? Let me do it for age, and then you will decide. Where is age? Here. Age. Okay. Which one is more symmetrical? Weight or age?
Weight is more symmetrical.
Weight is more symmetrical. This we call the tails. The tail on the right and another tail on the left. Here we have a tail on the right and another tail on the left. The tails, they should be equal. If they are equal, the tails, we call it symmetrical. They're pretty equal, but not exactly, because this midpoint should be in the middle, somewhere here. It is moved a little bit to the left. So the tail is the long tail is on the right. The long tail is very important here because according to the long tail, we decide whether it is, let me do it also for the height. Lastly, according to the long tail, we decide whether it is, this is height, you see. The long tail here, in this case, is on the left side. Depending on the tail, we decide whether it is right or left skewed. Whether we have the extreme values on the left, the outliers on the left, or on the right. If you have the outliers on the left, then the tail is on the left is longer. We call it left skewed. And if you have the tail, the longer tail on the right, then we call it a right skewed diagram. So histograms are usually used for numerical variables. Numerical. We can do it also for categorical variables, but then it would have no use. Let me see. Let me show you for a categorical variable. Is it possible to have an histogram for the sex? Yeah, theoretically it is possible, but how will it look like? Apply. Okay. Oh, what did I do? I didn't do a histogram. Chart builder, histogram, histogram of sex, histogram of sex, histogram of sex, yes, display error bars. You see, it's not possible even. It moves from histogram into a yeah. Is this an histogram? No. There are gaps. This becomes a column graph. So for the categorical variables, it's not possible to do the histogram. It is for numerical variables, and it uses what? It is used for to check for the distribution. To checks for the distribution. If tail on left, we call it left skewed. If tail on the right, we call it right skewed. This I will ask in the exam. Okay, so histograms are used for numerical data, and it is useful to check for the distribution, whether it is symmetrical or not, whether our variable is distributing symmetrical or not. The next graph or diagram is box plot. We call it also the box and whiskers. The box and whiskers. A simple box plot. Again, I need a numerical variable. Okay. This is a simple box plot of the weight. Simple box plot of the weight. And these stars and circles are showing the outliers and extreme values. For the box plot, we have a numerical variable, and it shows us the outliers
Extreme values.
or extreme values. Outliers are shown as circles. Extreme values are further outside. They are shown as stars. And these numbers here, they are the number of the participant in the variable, in the data set. Number 1, number 2, number 3. As you go to the data view, you see number 1 is 160, number 2, person number 2. If you would have ordered this in a different way, like sort ascending, and redo our analysis, chart builder, redo it, the same analysis, okay? You see, the numbers will change. This person is now the number 425 in the data set. 425. It's somewhere here down, 425. Here it is. 425 is the person with the weight 160. Okay. So this box and whiskers or box plot, or it can also be called the box and whiskers Whiskers is because it has a tail here, like a whisker, two tails, one up and one down. These are showing the 25, 25, and 75 percentiles. Here, minimum, maximum values. Here is the 25 and 75 percentile, and this dark line is showing the median values. So a box plot is giving us information about the outliers, extreme values, the median, then the 25th percentile, and the 75th percentile. Okay, it is a very useful, very good diagram to find the extreme values or the outliers. Here is another outlier. It is the person with the 33 kilograms. You see, it is also categorized by the SPSS as an outlier, not an extreme value, but it's an outlier. The person with the ID 213. Okay, so if I ask, yes, please. Banu.
I'm sorry. Why there is no X and Y values? Like why this?
You mean X and Y? Yeah, in this diagram, we don't have an X and Y axis. We have only the Y axis because it is only used for the categorical numerical variable. But it is possible to perform also box plots for different categories. Like here, let me try to show you. This time, let us say with a height by sex. Okay. Then we will have two box plots. We will have two box plots. One is for the male, the other one for the female. As you see, this time we have an x-axis here showing the categories. X-axis is showing the categories. Then the y-axis is showing our numerical variable. Y-axis is showing our numerical variable. And we have two box plots, one for the female, one for the male. Both the rules again the same. We have the extreme values or outliers, and we have the minimum and the maximum values. We have the 25th percentile, the 75th percentile, and in the midline, the dark color is showing us the median value. Okay?
Okay,
So,
thank you.
box plot is used for the numerical data, and it is helpful to display many features of a data, many features. Here I mentioned 4, maybe it is more than 4. Lastly, we have the scatter diagram. The scatter diagram, graphs, chart builder. Where is the scatter here? Scatter is here. Okay. Again, we have different combinations of the scatter diagram, but we will use the simple one. The scatter diagram is used for two numerical variables such as the weight and height. The weight and the height. Why I cannot move it? Okay. The weight and height. Okay. You see? Oh, it is height and height. I made a mistake, sorry. Weight by height. Weight by height. Yeah. Okay. Does it have a trend here? It's not very clear, but you know that as height increases, weight should also increase. As height increases, we expect that weight also increases. It is possible to draw this as an element here, fit line, total. Okay. You see, if I include the slope in the graph, you see that it is a positive slope. As height increases, weight increases also a little bit, but not too much. The multiplier is 0.5. Okay, so there is a correlation, we call this. There is a correlation between height and weight. Then the rule would be a scatter diagram is used for two numerical variables, or it can be also two ordinal, numerical plus ordinal. Ordinal for, you may do this, the same graph also for ordinal variables, but that's not so much preferred. Instead of height, I could have here educational level. Let's see how it will look like. Yeah, you see, it's not that much visually attractive, but again, we can have a clue whether weight is increasing or decreasing by the change of educational level. But as a general rule, we could say that the scatter diagram is best suitable for two numerical variables. In our example, height and weight, numerical variables, two numerical variables. Okay, so just let me repeat and then wrap up, close the session. We have here 5 different graphs which you should know in which conditions, under which conditions they are used and what is their benefits. The bar graph can be used for categorical variables, but it can also be used to display a numerical variable in different categories. So numerical plus categorical, I should mention. A pie graph is used only for displaying categorical variables. A histogram is usually used for numerical variables, and it helps to check for the distribution of the data. If the tail is on the left, we call it the left skewed. Or if the tail is on the right, we call it the right skewed distribution. And we want to, in order to perform the numerical tests, we want our numerical data, in order to perform the parametric tests, we want our numerical data to have an equal distribution, not skewed. The box plot is used for numerical variables, and it is very useful to display the outliers, the extreme values, the median, the 25th and 75th percentiles. And lastly, a scatter diagram is used to display two numerical variables, or numerical and ordinal. It may look for you difficult to keep all this in your memory. Go to the book if you want and read it from the book. It is also very clearly explained here in the book. But the best way would be that I suggest you to have install SPSS into your computer and do it by yourself, because by doing you will learn it best. Tamam mı Necla? Everybody learned this? Everybody has an idea?
Yes.
Yes.
Okay.
Idea.
Yes.
Please, if you don't understand it and if you have any questions or doubts in your mind, discuss it with me. I want you to learn, not just to present in the class. Okay, Dr. Azamat. For me, this session is closed. I think I reached my, we have here this Temen leaf plot, but this is not used, almost never used. Therefore, I will not mention about it. The rest, if the students are interested, they can go and read it from the book. These 5 diagrams I want you to master. Dr. Azamat, shall we close?
Yep. The time is
Okay.
5 minutes left.
Okay, so 5 minutes is not a big deal.